Hello everyone, welcome back to the channel. I hope you all are doing great. Today we are learning one of the most powerful and practical graph algorithm in data structure and algorithm, the Chinese postman algorithm. Think about this, a postman delivering letters, garbage truck collect waste, and robot clean floors, and street sweeper clean roads, like that. All are the face in same problem. How to cover every path, every road, every connections and using the shortest possible route. That's exactly what the Chinese postman algorithm solved. But by the end of this video, you all will clearly understand what is the Chinese postman algorithm means, what is important, and the idea of the lighter path and the circuit, the mathematical behind all, and even diagram vertex, and how non-electric graphs are converted, and the full step-by-step logic and the complex examples. So this is the perfect for question. What is the Chinese postman algorithm? What is the shortest possible path that visit every edge in a graph at the least one and return to the start point. So think every postman only go one house only one time. Then like that. The postman is the example. So I again tell the postman want to walk every street, deal the letters everywhere, cover all roads and come back home within minimum distance. So this is the focus in one edge, not the nodes. So this is the very important. In a Chinese postman algorithm, the goal is to cover edges, not vertex. It means every houses, not every road, like that. The main object is visit every edges at least once, return started point using minimum total distance and avoid unnecessary repetitions. If I get real world application, let's understand practically. The postman delivery must walk every street, and garbage collections must visit every road. Street cleaner, all streets must be clean. Robot navigation, all paths must be covered. And the network cable inspections, all cable must be checked. Pipeline inspection, all pipeline must be traversed. So this is the algorithm. Is not just academic. It used in arithmetic, robotic, AIs, smart clinic and automations. So graph theory foundation. Before the Chinese postman algorithm, we must understand linear. What is the linear? Linear means the mathematician who suited the graph's traversal. From his work, we get linear path, circuit, and graph. In the first, we talk about linear path or trail. So, linear path visit every edge exactly one. It doesn't need to return to start point. So this is the example for the linear path. For there are some nodes A, B, C, D, E. The nodes also say the vertex, and the line connected to each nodes called edges. And this linear trail, this goes to A to B, B to C, C to E, E to D. It doesn't want to start from one edge and finish from the same edge as we started. So next we talk about linear circuit. This circuit, a path that visit every edges exactly one, the same as the linear path. But this case, the return to the start nodes. But the linear path doesn't end with the start node, but the circuit does that. Like this. It starts from A and it's also end with A. So, but there are no any repeated edges. I mean, it can be repeated node, but it can't be repeated any edges. This matters because Chinese postman algorithm is basically converting the graph into an linear graph, then find the linear circuit. So Chinese postman equal making graph linear to find the linear circuit. So this is very important part. An linear circuit exists when the graph is connected and all vertices have even edges like this. So they have only 2 edges, that means even, or 4 edges or 6 edges. But the linear trail or linear path, the even exists also the graph connected, and it exactly 2 vertices have odd edges like this. It have 3 edges, 1 2 3 like that. And next, non-linear graphs. If graph has more than 2 odd edges or vertex, then it's not linear path, not a linear circuit, cannot be directly applied traversal. So key logic is every edges equal balance in entry and exit. Odd edges is mean imbalance. So important concepts. Chinese postman algorithm fix this imbalance by making all vertex even degrees. It means I talk about the trail had odd. We want to get it even. So I get its logical part. And now we start real algorithm. So step 1, we want to check the degrees of vertex. Count degrees of every vertex. If all vertex even, graphs already linear, just find the linear circuit and we can find it. And if odd vertex exist, we cannot do that. We have to convert it to even, and after that we want to convert it linear circuit and to. Second step, we find the odd degrees vertex. So create the list of odd vertex. For example, odd vertex have A, C, D, F. Those are problem vertex. Step C, pair odd edge vertex. Now we pair them in all possible way. If odd vertex are A, C, D, F, and possible patterns A, C and D, F, A, D and C, F, A, F and C, D, like that. Though this is called pairing combinations. Step 4, find the shortest path between each pair. For each pair, find the shortest path is distance between them. The previous video I talked about Dijkstra algorithm is also the same thing. Find the shortest path from one node to another node, and also Floyd Virtual algorithm is to all pair short path, but Dijkstra algorithm do single source shortest path. So now we know cost of the connecting each pair. Step 5, choose minimum cost pair. Now calculate the total cost for each pairing options. If you think we want to go to A to C, we have more paths. We can go A to B, B to C, or A to D, D to C, or A to B, B to D, and D to C, like that. But we want to find the shortest and minimum cost path. For think A to B, B to C cost is 10, and A to D, D to C cost is 11, and also A to D, D to C cost is same. So this the minimum cost is cost 10. It means A to B, B to C, and we find the shortest path. And 6 steps, duplicate those shortest path because we get odd path. The linear circuit can't do and include the odd paths. So we have to duplicate and convert into even ones. So this is change the degree of vertex. Now non-linear graphs and linear graph. All vertex become even diagonal algorithm. For those other vertex A, B, C, D, and edges are A, B, B, C, C, D, D, A, and A, C. And this is the graph, and there are some degree calculations. They also give. So A degree calculation is 3, B degree calculation is 2, C degree calculation is also 3, and D degree calculation is 2. And now I am draw the diagram and add some edges and connect. Now I'm going to do this using linear circuit. So before I said linear circuit have uh, even edges, but the A and C degrees calculation is 3. We can't do that, and we have to convert this 3 and 3 A and C into even numbers. What we can do, we can get this A and C duplicate like this, AC and duplicate, and I connect those two together and get 4. The both edges are become 4 because two edges connected mean 3 plus 3 not 6. It's be 3 plus 1 become 4. This we only added 1 for that, and next it's work like this. The all degree calculations are become 4, and uh, next step is we can find the shortest path from these nodes. I want if you think you want to go to A to C, you have lot of path. You can go A to B, B to C, and A to D, D to C, or directly to A to C, like that. So next we doing the linear circuit part. Before the first we were doing find we check we can directly connect those. It means these all degree calculations are even. We can convert it to linear circuit, but this example the A and C is not even, it's odd numbers. We have to convert it into even numbers. Now we did it, and now we have to find the linear circuit. Now we apply traversal. In my previous video I've talked about the traversals, and you can start from any node and traverse all edges once and return to start. This the route is called Chinese postman path. This is I got A to C, and there are a lot of paths I already told. And if you want to go to B to D, I also have a lot of paths. And like this is the example. So 7th step, find the linear circuit. New apply the flow algorithm or other algorithm. So another video I tell what's those algorithm. Then we finally traverse and path and find the Chinese postman route and the shortest and